Thank you very much. Good afternoon, everyone, and welcome to our presentation, Plug in the Middle. First of all, I'm going to introduce myself. I'm Alejandro Espinosa. I have a degree in computing engineering. I have a master in cybersecurity. I have experience in ethical hacking. And I have also developed challenges for CTFs. I am Julio Martinez. I am also a computing engineer by the University of Granada. I have a master in cybersecurity by the University of Carlos III in Madrid. And I also have experience in deployment of security infrastructure and ethical hacking, and I am in charge of vulnerabilities management in Orange, Spain. We will start with a brief introduction. We will tell a real case which happened to us and made us think about this topic. We will see how the protocol of PLCs work, what attacks can be carried out against this kind of protocol and devices. Then we will explain to you some laboratory testing and the results we obtained. We will use a demo to see how these attacks work, and we will finish with some brief conclusions. I guess that most of you know what a PLC is. For those who don't, PLC means power line communications, and those devices are frequently used at home because they transmit internet through the electricity grid, so that the internet can be transmitted to remote parts of the households. It uses the home plug AV protocol, a standard, and a typical architecture of this kind of PLC network is as the one that you see on the screen. The internet, the devices connect to the internet network, and then a PLC is used to transmit data, for example, a Wi-Fi repeater or so on. I'm going to tell you about a real case that happened to me and which was what led us to research on this topic. This happened to me this summer when I moved into my new house. Before moving in, I needed internet, which is the most important thing, so I called the company for the router and everything I needed. The thing is that I had hired a TV decoder, and I had a logistic problem. I couldn't connect my Wi-Fi to the TV decoder. So what did I think? Okay, I could install a long wire and cable, but that was not the most appropriate solution. Another alternative would have been to move to change the location of the TV, but I didn't like the distribution in my flat. So the most feasible solution was to use PLCs. One of the devices is connected to the Wi-Fi, the other to the TV decoder, and the logistic problem is solved. I had this at home, which is a TP-Link AV500. But then I found some abnormalities. I noticed the internet was a bit slow, so I thought, what the hell? I had hired 500 megas, why isn't it working? So I accessed the setting panel of my router, where I found that the router that I was using was not the one that I had installed. I mean, I had one internet company, and the router belonged to another company. So I started looking for this router in all the rooms of my house, because maybe the landlord had installed a new router. I didn't know what to do. I was about to call a medium to resolve the problem, but then I I did this. I entered the code of my router, and this was the results of the search. I didn't understand how this was working, and this was my face when I discovered it. In order to shed some light, I thought, this has to be a scientific explanation. So I used the tool of NetDiscover in order to scan all the devices, all the local devices which were connected. There were two devices that were using the same IP address. In this case, 11, the address of the router. So there were two devices which were competing to be the default gateway, and that's the reason why sometimes I could find one router and sometimes the other one. So I accessed the panel of setting, the setting panel of the router. Fortunately, nowadays we can access the device directly. So what I did was to change the setting in order to give another, to have another IP addressing. So the test, once I had set everything up, I realized that the speed was good, the gateway was good, so I digged in a little bit more in order to know why this was working. So in the range 1.1, I did a static IP, and when I was in the point number 1, I was having a Movistar static IP, and when I was using the second one, I was using the Orange router. So in the first case, we realized we were using Telefónica's internet, and on the second case, I was using Orange internet. So once at work, I said, look what happened in my house, and I shared the story with my colleagues, and one of them said, yes, the same happened to me when I installed a PLC at my place. The internet wasn't working, I could see devices that were not mine, and I thought, okay, this case is similar to mine. So I downloaded the manufacturer's tool, which in this case is TP-Link, and in the setting panel I found a parameter which you can see on the screen. It was a default there was a default checkbox, so I thought everything which is default is wrong, so let's change it, and let's assign it a different network link. I change it, and automatically the network 1.1 disappeared completely. I didn't see any weird devices, the internet speed was good, so the conclusion that I could extract from this, that the default password comes in every device, and users can have some troubles. So to sum it up, our network was overlapped with the neighbor's network, and we could see every device that my neighbors was using. We could use his router only by having a cable installed into our electricity grid. And the other way around, it was the same. He could see all my devices. So the physical layer is not being segmented, which means I can be in my neighbor's flat without any physical barrier preventing this. And on the other hand, if my neighbor has a PLC whose password has not been changed, it is going to work properly, but it is exposed to this kind of attack. So in the end, all the security lies on the final user, and if you're not aware of this, it can happen to you. There are new ways to attack Wi-Fi. It is not necessary to to do math. Just using a cable connected to the electricity grid, we could access my neighbor's internet. Once this happened, we started to do some research in order to understand properly how PLCs work, because we wanted to go far beyond. It seemed that these PLCs are not as secure as we thought they were. So let's explain now how this protocol works. And then we will see what kind of attacks can be carried out against this protocol. The protocol uses layers 1 and 2 of the OSI model. It overlaps a wave, the one that transmits signals, over the layer of the traditional signal, and that's the way information is transmitted. There should be something that could prevent the dissemination of that wave to other flats in our building, for example. And this device should be installed in the building facilities. Then there is something called chokes, which could stop the wave from disseminating. Manufacturers do not usually incorporate this component, or this component may not have all the necessary barriers. So as for PLCs, all the flats in a building could be interconnected. And even between different buildings, this could happen as well if they are close use, as manufacturers says, use different kind of encryption, which is implemented between one PLC device and another PLC device. Between the PLC and host, you don't need that encryption. One of the most important concepts to understand is this. AVLN, it is AV Logical Network. Since PLCs are connected to a shared medium, it will be like a bus topology. They generate VLNs through cryptography. All PLCs within the same VLN share the same keys, and in this way they can be isolated from external PLCs that could access information from our network. All the PLCs within a VLN are called stations, and one of them is the Central Coordinator, or CCO. This Central Coordination is responsible for the authentication of new PLCs which want to be connected to the VLN, and it also sets up some parameters such as modulation. It also renews the encryption keys that all the members of this network use. In order to better understand all the encryption mechanisms they use, let's explain the 4 keys that are used in the home plug AV protocol. First one is the network membership key, which is the one used by stations for the authentication against an AVLN. Then we have the DA key, which is device access key, which is a unique key for each device, which is generated by the password printed on the back part of the PLCs. It is used to exchange the NMK in a safe way. The following one is the NEC, Network Encryption Key, which is used by all the PLCs in order to encrypt all the stations within an AVLN. Finally, we have a TEK, Temporary Encryption Key, which is used in the mechanism of key exchanges in order to do it in a secure way. The two most important keys are the two first ones, network membership key and device access key, because they are going to be attacked in order to access external networks. Both keys are derivation from other passwords. The A key is a derivation of the password printed on the device. How can we generate, how this derivation works? It uses a function called pvkdf1, which is public and has 5 criteria: password, then salt, a hash function, a number of iterations, and a hash length. Therefore, all the NM key and DA key are going to have the same length. Out of these criteria, we know 4 because they are fixed and defined in the protocol. Salt is fixed, a hash function is the same, the number of iterations is 1000, and the length is 16. So all the DA key and NMK have a length of 16 bytes. In order to go in depth of this key generation, we carried out a test. In order to do so, we took the PLC. You can see the tag on the device where you can see the MAC address and the password. And in order to do so, we used the tool, the manufacturer's tool, which also included the same information than the tag on the device. In order to generate the DA key and NM key, we used an existing script which uses the DA key or NM key and generates the derivation, which is the one that you see on screen. To see that it is doing it correctly, we used the manufacturer's tool. We set up a PLC remotely, and then, thanks to this, the tool will generate the NMK and the DAK to the PLC. If we compare this to we can see that there are 2 fields. One is the NMK and the other one is the DAK. We can see that the DAK is the one that we generated through the script. So we managed to do it. Once we have generated the DA key and the NM key, we can see how these keys can be exchanged in PLCs. There are 3 mechanisms. The first one is when there is a direct connectivity through an Ethernet cable or through a router or a switch. The host gives the PLC the key without any kind of encryption or authentication process. The 2 following ones are for remote PLCs or who can be connected through the electricity grid. The first one is the DA key-based NMK distribution protocol, which sends the NMK to the DA key in an encrypted way. You only need to establish this mechanism so that no other devices can detect it. So this individual password from the PLC is encrypted, and only the final user can de-encrypt it, decode it. The following mechanism is the UKE, and it is for devices which have a matching button. When they receive the signal, after pushing the button, both PLCs will exchange some hashes, and they will build a temporary key, and it will be sent to the other device. Once the NMK has been exchanged, it needs to be authenticated. They will send a packet to the CCO in order to ask for authentication. The CCO will receive the NM key, and then if it matches with the one it has, it will enable the authentication. Let's see a more practical example. We have a user that wants to set up two different PLCs. One has direct connectivity through the electricity grid, the one above, and the below box is through a network. As for the local one with the manufacturer's tool, you just say the network name, the name of the network you want to set up, and then the PLC would receive this packet without any encryption through a Ethernet platform. As for the remote case, the user would need to give the password and the network name. Then the program will derive both keys and will send the remote device the NMK encrypted through the DA key. Once we have already understood how keys work, let's move on to the interesting part, attacks. When we started to do some research, we reviewed the state of the art, what was in the market, all the tools, and so on, and we realized there were very little research on it. The most recent one was published 4 years ago, for example, and we only found all these attacks. The first one is quite easy through LAN connection, and the third and fourth are for remote attacks, which are more interesting to us because with them you can steal Wi-Fi from your neighbor. The first one is interception, which would consist of trying to set up the network name, and in order to do so, you would need to be in between the communication with the final user and the PLC itself. This is very improbable because usually PLCs are only set up once when they are installed, so it is quite unlikely. But there is another way of doing it. As I said, any PLC is going to accept any DA key change through direct connectivity with a local connection without asking any questions. So if you had this, you could send it a packet asking it to change the network name. The advantage is that you don't need physical access, but if you manage to do so, you can change it. You can change the network name, plug in our PLC, rename it with the same name that we sent to the other one, and then we would already be connected to the router. The second attack is a remote one, and it would be to exert brute force to the NMK. For example, through a dictionary attack. We try to search for this attack, and it wasn't done, so we implemented it. How does it work? We have a PLC which acts as an attacker, and we change the network name of this PLC, and we ask it if it had been connected to any network. Once we have found a network, then we have found a network name, which can be useful for us. However, we were quite disappointed because an attempt took us 7 seconds, which is the time used for the authentication process of the attack. 7 seconds for a complex password will not enable us to obtain the password because we could spend years and years trying to find it. Then we found a much more interesting attack, which was invented by Sebastian Dudek. Its name is KO-DAC, and instead of attacking the NM key, it attacks the DAC. This person realized that there is a pattern in all passwords, which gave us a combination of, as you can see on the screen, I cannot even say the number. It would be impossible to use brute force against this. The program by the manufacturer was able to recover the password and to show it to the user immediately. And there was a question that arose from that. How can it recover it immediately? What did he do? He did reverse engineering to the program, and he realized that the password is not randomly generated. It is generated through the MAC address. Obviously, he realized it was a huge security problem, so he reprogrammed the algorithm and could recover the password through the MAC address of the device. So we do no longer need a password of the PLC in order to control it. You just need the MAC address. We have two cases regarding this. When the PLC is the attacker, the CCO is going to emit some icons in order to get the MAC address. For the rest of the stations, it is more complicated because they cannot emit any beacons, so we cannot know the MAC address instantly. However, we can exert brute force. Instead of exerting brute force to the PLC, we do it to the DAC. So we have reduced the possibilities quite a lot, as you can see. But we can do more. Usually the rest of PLCs are going to belong to the same manufacturer, so because usually they are sold in pairs. So we can assume that they are going to have the same vendor bytes than the CCO. So we have reduced it to 256 with an exponential of 3, which is a significant reduction, and it will be much more easier to do it. And let's talk now about the testing we have carried out and the results. I am going to talk about the laboratory testing. This is much more practical than what Alejandro was telling us. What we did was to start with Sebastian Dudek's research in 2015. And it includes a toolkit to carry out attacks to HomePlug AV. It implements the attack Kodak. It also included the script, which, as we saw, was generating DA key and NM key password generation. And we have other interesting functionalities, such as the discovery tool, where you can see the MAC addresses of devices, and then we have the demonetization tool, which doesn't take into account the beacons. We realized there was room for improvement in this repository, so we carried out a fork. We realized that we implemented the NMK dictionary attack, which is quite interesting. We carried out another script, the set local NMK, which is quite interesting because if we have a PLC behind the router, we wouldn't see it, but if we do it with the set local NMK, it will be much easier because we are connected to an Ethernet network. Then we also corrected bugs because there were some exceptions which were not properly controlled, and the information was not completed, so we added some more information.
These are the battery of PDC devices that we've used. Most of them are TP links, some of them link. They use different type of protocols. The most modern one allow for a 1000 megabytes per second speed, and as they are using the home plug new algorithm, this allows for more speed too. So we've seen that the LAN attack can be done to any of them, because this is related to sniffing packages in the network. NMK and the AK also can be attacked through brute force, and KODAK is the most efficient one. And we've seen that attacks can happen to most of them, but for the most recent ones, because probably the manufacturer has changed the algorithm, so it's not possible to attack them that way anymore. We've built a demo. This is the scenario that we are going to represent. We have a legitimate network with a laptop. In this case, we're going to use Alejandro laptop. And then we have a Raspberry Pi that can be also in a home. Both use VDL devices, and I'm going to be, so to speak, in a different floor using a different PLC with the computer of the attacker, and we would be completely isolated. We thought that he would be smart enough to change the default password. It's not home to plug no more, so this is why the test is more difficult.
Bueno, primero vamos a enfocar con las cámaras cómo estaría el entorno de laboratorio. El entorno de laboratorio. Vale. No se está viendo. Vale. No se ve. No se está viendo. No se ve. Podéis poner la pantalla. Es que no la tengo que poner yo. Espérate, es que la tengo que poner. Es que no la tengo que poner yo. Espérate, es que la tengo que poner así. Duplicado. Vale. Un segundito. Duplicado. Vale. Vale, ahora se ve.
Bueno, este es el pequeño.
So this is the small scenario that we have. These two PLCs are coupled, and this is the PLC of the attacker. I don't know if you can see it properly, but we have here some LEDs. Here we have the three LEDs on, and in the attacker one there is a LED in the middle which is off. This shows if it is connected to a VNL or not. So this is the vision of a user. The REM home plug view would be that one. You could be able to see both devices. So now if you look at my tool, this is the view that I have from the point of view of the attacker. I'm not coupled with any device. I'm using a completely isolated device. Are you able to see the screen properly, what I'm writing? So these are the scripts that we've mentioned before. First of all, we are going to check what devices we are visualizing. This is why we are using this script discovery. We can see that there is one station. So this is my PLC device. I don't know why we cannot see the rest of them. Normally, we usually can see more different type of devices besides our interface, but well, this is the PLC that is connected as attacker PLC. I'm going to give this a MAC address. I'm going to type this, and with this information I'm going to have my own MK password for my own device, because I want that the other network, the other two PLCs use the same password. So I'm going to set a password that I already know. With the -k parameter, I could introduce one, but as a parameter, I'm going to leave it blank, which would be like typing zeros. Then I have sent a success message, which means the exchange has been done successfully. So the next step that we are going to do is to analyze which remote CCO exists in order to see to which we can connect. We've seen that the network is being analyzed, and we found this station. But well, this is the one that we want to check. So this is the remote PLC that is being a CCO of the network that's connected. So we're going to keep that address, and we are going to execute the KODAK attack. So before launching the attack, we are going to analyze the script so that we understand what we are doing. So this is it. First part involves the parameters introduced by the user. So here we can see the password established by default, which is 000, and then we have another address that is being spoofed that could be changed to. Here we have a loop, so in case we are adding a MAC address which is not complete, this is going to be completed by using brute force. And this would be the second phase of the attack, that would involve attacking stations that are not visible. And then here we would have implemented automatically the fact of taking a MAC direction and translating it into a DAK key. Here we would use that algorithm in order to put it in the right format. And finally, we would be sending it by using the appropriate library. Now we're going to launch it. We're going to launch the attack. This would be the CCO. And as you can see here, we are having automatically the DAC. Once we have the MAC address, the algorithm can act quite fast. We're going to eliminate the dots here so that it works. We've sent the package. I mean, this is going to send the DAK that has been generated automatically. And if we update our view, now we should be able to see the device. So here we have it. So what we've done now is to configure the MK automatically to the central coordinator of the network, because this was in charge of issuing the beacons of the network. But now we have an isolated PLC, and this PLC is not emitting beacon because it wasn't in charge of that. So we cannot figure out the MAC, the MAC address, and this is why we're going to use the brute force. We are going to last vendor bytes, the ones that belong to the device, and now we would have to try with all the addresses until we find until we find one of them that is useful for our objective. I'm not going to do the whole process because it can take a while, but the result could be this one. And here you can see the third device, and we would have completed our attack successfully. From this tool, for example, we would be able to change the password to all devices at the same time. For example, I'm going to write down CyberCamp 2019. And for example, if we take a look with the camera, we are going to see that the LEDs are shining, so it means that they are coupling with a network. They are exchanging information. So this one has already been coupled, and okay, now all of them have been coupled. So let's see if this is synchronized. Okay. So we've seen that this attack works quite well. It is quite fast. The problem is that we are going to interrupt the service for a period of time. So let's see the advantages and disadvantages of the other type of attack, an MK dictionary attack. In order to go back to our previous dictionary, I'm going to put the local key here in my device, and therefore this is going to isolate me from the network. So I'm already out the network, and now we're going to do a brute force attack. One of the parameters is going to be the MAC address of my own device, because as we've said before, this uses my own device in order to see if I can couple with a network by just testing passwords. So we have to, of course, type a dictionary that we've had prepared with a password. So now this is configuring itself. One of the words that we've written in the dictionary is being applied to the device. So when the device is coupled, we're going to ask if it has linked to a network. If the device says that it's already linked to a network, it means that the attack has been executed successfully. Here we've managed to obtain a password in the last line, which was in the dictionary, and this has allowed for an automatic coupling. Now we are inside the network again. So the advantages is that this is not disruptive. This algorithm is able to put in the middle without interrupting the service, and it doesn't imply attacking the network of the neighborhood of the neighbor. It is us who are changing the NMK, but it lasts longer, and maybe sometimes it's not possible to work that way. And finally, as a conclusion, well, as we've seen, the PLC devices are very much used in houses, but there is not a lot of information about them, and they are vulnerable to different attacks. So, well, we've realized that research in this field could be further promoted, and the newest protocols do not even have implemented protection layers that should. Also, regarding the reversing that Dudek did to Qualcomm, we could see that it was done through this manufacturer, which is the most well-known manufacturer, and all PLCs use this manufacturer, and this is why the KODAK attack is so useful. But there are more manufacturers, and if we do more reversing on other manufacturers, we would increase the scope of vulnerable devices that may be found. And regarding mitigations, we've seen all the attacks, but how can we avoid someone to attack us like that? Well, first of all, we have to change the password by default, because this is the worst thing that you can do. Also, we have to check if PLCs are vulnerable to KODAK. How can we do that? Well, when look at the reverse of the PLC, we can see the password that we have. So if by using the algorithm we can generate it by just using the MAC, we're going to be able to suffer that attack. Regarding chokes, it depends on the electrical installation of the building. We cannot do anything about this, but we can, for example, try to use the discovery script in order to see which devices can be found in the building. For example, if there are 4 or 5 CCO stations, probably you're not going to have 5 or 4 PLCs in your house. Probably there will be someone emitting the sign. Regarding using strong passwords, this is very important in order to avoid the dictionary attack that we've seen, even though we've said that it is a very long attack, but anyway, would recommend not to write passwords as 1, 2, 3, 4. And if you want to avoid LAN attacks, you should de-enable the ports in the switch. So, well, it is very complex for that this happens. It is unlikely that this happens, but the most important thing in order to avoid these things is not to let hackers enter into your house. That could be the easiest solution. And, well, regarding the bibliography that we've used, we can find the works done by Dudek, which is the most recent research in the market right now. Then we've used other papers regarding home plug AV security mechanisms, and also an essay from 2010 with a lot of information on that too. But well, this is it. If you have any question, please feel free to ask. We will be glad to answer your questions. Would you recommend using PLC or Ethernet long cables? What's the best solution? You can use a PLC if it is well set up. And the speed, is it going to be the same, or am I going to have more? Well, you're always going to have more speed with a cable, Ethernet cable. A straight cable is going to work better always. But let's imagine that you have 2 floors. You cannot use the cable in 2 floors. But well, the most recent devices offer quite good speeds for streaming and everything. If you have a laptop on the other corner of your house and you don't want to use you cannot use a cable, a PLC is a good solution, but it must be properly set up. Are there any more questions? My name is Manuel, and I have a question. When you do the KODA attack, you are exposed, right? You are not protecting yourself. That's right. Yes, the neighbor is going to watch you. Same thing, you're watching him. Same thing happens when you are hacking Wi-Fi. You end up being exposed. And could we use different brands of PLCs in order to do this attack? Yes, it's possible. In fact, HumPlug V2 is compatible with other brands. So these are TP-Link, but we've run tests with other PLCs from other brands, and they couple the same way. And what I didn't understand at the end is when you introduce yourself in the network, you are a master or a user, normal user. No, the master is the same one that is the master from the beginning, the device that is emitting a signal. Well, good afternoon. Thank you so much for the presentation. It was very interesting. I have a question. 2 weeks ago, it happened to me the same thing. It happened to your colleague. I have a D-Link, the HP, and when I tried to see who was connected, I could see iPads, well, thousands of devices from other neighbors. So I tried to close it because I wanted to avoid anyone to enter into my devices. Regarding what you've said, would I be able to solve the problem like that? You have to change your network name. Just with that, you're going to avoid that problem, because cryptographically, what you are doing by that is limiting. your device. Yes, if you change the network name to both PLCs, that would solve your problem, that would isolate you. But we cannot ensure if your PLC could be attacked with KODAK. Well, I think that mine wouldn't be attacked by that. If you're using that one, yes, then the KODAK attack doesn't work. Okay, thank you. Now I don't have to run the test myself. Thank you. Are there any more questions?
Una pregunta más. Nos queda tiempo. Animaros, nos queda tiempo.
We have a few more minutes, so please feel free to ask any question you want to.
Por allí, ahora salen dos. Por allí, ahora salen dos.
Buenas, gracias por la charla.
So thank you for your presentation. I wanted to ask you something. If you have the same network name, the fact of obtaining the MAC from the master so that you can cheat it and be accepted in the network, how is it done automatically when this happens by chance? I mean, why, if this name is by default, can I be incorporated into the neighbor network? Well, the key that we've said that is generated from the network name is going to be compared if it and if it matches, it's going to couple you with that network. If you connect the PLC with the network, it is going to check the beacons that it's receiving. So if it says, okay, there is an VLAN, it's going to try to authenticate with the VLAN with the network name that has a configuration. So you always have to change passwords by default. Just because sometimes you're changing your key all the time until you are coupled. This is one of the attacks that we've seen before. Yes, in the end you just have to test the different possibilities that you have until one matches. Hello, good afternoon. So, well, I'm kind of ashamed to ask that question because I missed the first minutes of the presentation. I'm sure that you mentioned this. I've been using PLCs for many years, and I thought that they should work within the same electrical circuits, right? Yes. So the electrical installation has more circuits. Is it more safe? I mean, as far as I understand, I'm isolated from the rest of the neighbors, right? Well, in the electrical installations of a building, there are circuits for different types of appliances, but in the end, they are all linked to the main PLC. So, as you can move from one floor to another, you need to take into account that counters can be hacked. And are there any more questions? We have more time for some more questions, 2 or 3. Well, thank you very much.